tutorial of microbiology with Shagni. So in this video tutorial we are going to discuss our second part of Sds Page. So in previous video regarding Sds Page we have discussed about the basic principle of Sds Page, and now we are going to see about the application part and some small questions related to Sds Page. So let's start the application part. So application, we can quantify protein, we can use this in blotting application. Remember that Sds Page is widely used in case of Western blotting technique. Okay, identifying disulfide bond during protein, determine molecular weight of the protein, determine purity of the protein sample. So we can determine the molecular weight, we can determine the purity of the protein, we can identify the number of disulfide bond between protein. Blotting application and quantifying purposes, quantifying protein purposes, our Sds Page can be used. Advantages: migration is strictly based on the molecular weight, so that the separation can be highly sensitive. It separates 2% differences in molecular mass, requires small amount of samples, stable chemically cross-linked gel. Disadvantages are the poor band resolution due to high alkaline operating pH. Acrylamide gel is a highly reported neurotoxin chemical. This is an important question too, that what kind of neurotoxin is commonly used in case of biological molecule separation, that is acrylamide gel. Gel preparation is difficult because remember, in discontinuous gel we are using stacking and dissolving two type of gels to their different pH, different concentration. So preparation of them is not a easy joke and require longer time, highly cost. So in application part we have seen that quantification of the protein is possible, molecular mass determination is possible, identification of disulfide bond between protein is possible, blotting application is possible, purity of the protein sample is possible. Then we have seen the advantage part, where we have discussed that migration is strictly based on molecular mass, so that the separation of the proteins on the basis of molecular mass only. So the separation is in turn highly sensitive, and it can separate 2% differences in molecular mass, requires small amount of sample, stable chemically cross-linked gel. Disadvantage: poor band resolution due to a high alkaline operating pH. Acrylamide gel is a potent neurotoxin chemical. Gel preparation and required high time, highly cost. Now let's talk about some conceptual part. So we have discussed that vertical gel electrophoresis is our page, right? So page is in turn divided into two parts. One is discontinuous gel electrophoresis, another one is continuous gel electrophoresis. And discontinuous can be divided into two parts. One is SDS, another one is native, right? So in discontinuous gel electrophoresis we are using two kind of gel. One is resolving gel and stacking gel. So here we are going to discuss about the stacking gel a little much, although in our previous video we have discussed it about in little bit. So 4% acrylamide gel concentration is used. pH will be 6.7 to 6.8. The addition of that stacking gel here is why stacking gel is used, because here remember, you cannot understand it either. I will try to explain this to you diagrammatically. So suppose this is the gel and here is the well where we will add our protein sample, right? So suppose this part is stacking gel, upper part, and lower part is resolving gel. Now the question is why stacking gel is necessary, because remember, if we use a continuous gel then the protein separation will be haphazard. Okay, so that is why our idea is to concentrate all the proteins in one band before their separation in running gel. That is why we use the stacking gel, whose pore size is greater than the resolving gel. Okay, that means stacking gel's main purpose is not separation. Here we are just concentrating protein molecules in one band to start the migration in running gel. Okay, so the real separation in case of discontinuous gel electrophoresis occur in case of resolving gel. So need to concentrate all the protein in one band, so they will start migrating in running gel all at the same time, okay, so that the separation will be accurate. Resolving gel 5 to 15% of the acrylamide gel concentration and pH is 8.8 to 8.9. Resolving gel allow to separate protein based on their molecular weight. Now here the native page. I have discussed with you about native page in previous video already, that in that native page the intact protein is used for separation, right? Protein may be run in the native state, that is tertiary and quaternary structure. That means here we are not using any kind of heat or denaturing agent or SDS, right? So protein may be run in their native state. Proteins are amphoteric in nature. Why proteins are amphoteric in nature? Proteins are amphoteric means they carry positive charge, negative charge or zero net charge depending on their pH of the environment. Let's see how. It is a amino acid which is in its zwitter ion. Now let's see what happens if we increase the pH of the environment. Increase of pH means, remember, there will be too much OH minus ion in the environment, okay, and in presence of too much OH minus ion, what will happen? This H3N will simply donate it hydrogen, okay, to convert this OH minus into H2O. So our structure will become CHRCOO minus, because here there is no H to donate, so the entire net charge of the amino acid become negative. So as we know that protein is nothing but made up of amino acids, so we can conclude that the same funda will be applied in case of protein too. So if the pH of the environment is greater than Pi, and now what is Pi? Pi is the point in which the protein do not migrate towards any of the electrode, okay. So if the pH is greater than the Pi, that means the pH of the environment is basic, then there will be too much OH minus ion in the environment, so it will ultimately give the negative charge. On the other hand, pH less than Pi means the environment is acidic. That means in the environment there are too much H plus ion, okay, and in presence of too much H plus ion, the CO minus simply takes H plus and converts itself into COOH. So our entire molecule become positively charged. That is why when pH is less than Pi, the molecule become positively charged, and that is why proteins are ampholytes, right? They become positively charged or negatively charged or zero net charge depending upon the pH of their local environment. Now the question is why when they become zero net charge? When the pH of the environment is exactly equal to the Pi, they become zero net charge. That does not mean that they do not possess any kind of charge. Instead, it means that the charge is neutral. That means number of positively charged molecules in the protein is exactly equal to number of negatively charged protein. That is the idea. You have to remember one thing, that protein cannot be without any charge, any kind of situation, right? They become neutral in charge. That means number of positive charge and number of negative charge become same. That is the idea. Now the question is, can we use SDS page for separation of nucleic acid? I have already discussed with you about the use of SDS page in nucleic acid. Try to remember where. So we have used SDS page in DNA sequencing with the help of Sanger's method. I hope you remember. We have discussed Sanger method DNA sequencing in our recombinant DNA technology section, right? So that means we can use Sds Page during nucleic acid separation, but the condition is the molecular weight should be below 500 kilodalton and the gel percentage will be 6 to 8%. Okay, so that is the condition that you need to remember in your mind, that if the molecular weight is less than 500 kilodalton, so by using the gel concentration 6 to 8%, we can use Sds Page for nucleic acid separation. And one application of Sds Page in nucleic acid separation is the Sanger's method of DNA sequencing. Now, why page for protein? Question, a very important question for both university exam and the all kind of MSc entrance exams too. So why page is important for protein, but why we use page for protein? So the idea is, remember that polyacrylamide gel is made up of acrylamide and bisacrylamide, that is N prime methylene bisacrylamide. So they together cross-link to form a gel or matrix which consists of a relatively smaller pore size. Okay, but in case of agarose gel electrophoresis, the pore size is relatively larger than the page, and here the protein molecule is usually smaller than the nucleic acid. That is the reason smaller porosity, that is acrylamide cross linkage, is for strictly protein, and larger porosity, that is our the agarose cross linkage, is for DNA and RNA. And you have to also remember what component helps in cross linkage of acrylamide. We have discussed already TMAD and APS, ammonium persulfate. So now the last topic of today's one, that advantage of vertical gel electrophoresis over horizontal gel electrophoresis. Remember, unlike horizontal gel electrophoresis, in vertical gel electrophoresis, the buffer, suppose if it is your gel, then the buffer will be here and also here. So the buffer will flow only through the gel. So it allows precise control of voltage gradient during separation. Okay, because buffer has only opportunity to flow through the gel, so we can control the voltage gradient during separation. And when it is combined with small pore size of acrylamide, greater separation and resolution can be achieved as compared to the horizontal system. So that is the advantage of VGE. The most important advantage of VGE is that the buffer can only flow through the gel, so that we can easily control the voltage gradient during separation. And another important one is smaller pore size of the acrylamide gel. When combined with vertical gel electrophoresis, it provides greater separation and resolution as compared to horizontal system. That is why vertical gel electrophoresis is often combined with page, not with agarose gel electrophoresis, right? So that's it for today, guys. I hope that this video will be helpful to you, and please hit the like button if you have understood it well, and share with your friends and subscribe to my channel to get more videos like that. I will again come with another video where we are going to discuss about the isoelectric focusing, another kind of protein separation, where we are going to use another kind of physical properties to separate the protein. So till then, bye bye.